Welcome, Liz. It's great to have you on the show. How are things?
Chris, thanks, Hayden. Happy to be here. Everything has been great since we last chatted.
Yeah, great. Lovely sight out the window behind you. A little bit better than my background. It looks pretty sunny there, actually. What's the weather like?
It is. It's pretty chilly, in the 30s Fahrenheit, so pretty chilly, but a beautiful day, which definitely improves what we've had the last couple of days. So very nice.
Great. Yeah. Well, as I'm sure you imagine, typical English weather here. It's been chucking it down with rain all day. But there you go. What else would you expect? All right. Well, I want to get into the meat of the conversation, and then we'll come back and we'll cover some of the stuff that actually we touched on in the previous episode in 5 or 10 minutes or so. But GlobalX recently released Charting Disruption, your latest report that we ourselves at OPTO look out for every year. Some really amazing information and statistics in there. And one of them that stood out to me was GlobalX's prediction that gene therapies are leading a market forecast to be worth $50 billion by 2028. So perhaps just to set the context for this conversation, give us a sense of what that market is worth now and the key contributing factors to that huge growth moving forward.
Yeah, no, perfect. And again, in terms of Charting Disruption, sort of our flagship product, sort of chatting through our expectations across the board, really not just in terms of healthcare. But when you look at the healthcare space, cell and gene therapies are certainly an area that we're very encouraged by. And before I sort of get into the numbers, I want to explain what we mean by cell and gene therapies. There's a few different technologies that are considered part of a sort of broader bucket. It could be anything from gene editing technology, so actually editing the DNA to cure an illness, to cell therapy or gene therapy. It's a more novel sort of drug category, starting with the first approval, at least in the U.S. in 2010. In the U.S., we currently have 23 approved therapies. So a little bit of context as to perhaps where we're excited to see a lot of that growth. So for context, 2022 had about $5 billion in sales for this group of technologies. 2023 saw about 6.8. And we do have high expectations for revenue for this category through 2028, as you mentioned, around $50 billion. There's a few reasons why.
Technological innovation is causing unprecedented disruption. OPTO is here to help take advantage of a world in flux. From AI to blockchain, find the stocks and ETFs related to 50 plus powerful growth trends. Just scan the QR code to download for free.
Again, the sort of category is quite new. But again, when we're talking about these technologies, they're very unique in a sense as to perhaps compared to the broader pharmaceutical sector. We're talking about treatments with curative intent. They obviously use very novel technology to address the underlying factors that lead to illnesses. So again, if we think about a patient has a specific mutation in their DNA that then causes them to have, for example, hemophilia A when they're an adult, we're sort of nipping that at the bud directly in terms of the DNA. Again, when we have that curative intent, it's really exciting, right? When we're talking about illnesses that are highly cumbersome, that require patients to go have transfusions or infusions multiple times a week, it has not only significant sort of value for the patient, but just in terms of their overall lifestyle, right? It can be quite meaningful. So it's a very novel sort of area. But again, we're starting to see a lot of acceptance from regulatory bodies in the US, in the UK, and abroad. We're starting to see a lot of work to expand the sort of illnesses that are currently being targeted by these technologies. So I would say it's a very exciting time to sort of be looking at the broader genomic medicines market.
Yeah, absolutely. And perhaps to start then, to make it a little less abstract, we can focus in on some specific examples of how those genomic technologies are being used to address common diseases through both direct and indirect approaches as well. Are there any particular examples that spring to mind?
Yeah, there's a few, and perhaps sort of pinpoint the differences in technologies that we have sort of available more broadly. One of those is gene editing. We just, of course, saw late last year an approval for Casgevy. It is a particular gene editing treatment for sickle cell disease. That again, sort of underlying the underlying issue in the DNA, it sort of corrects it and thus again has curative intent for the patient. That's one where I would say, again, the sort of the more novel category within genomic medicine, but a really exciting sort of bucket within that. The other example I'll give is, for example, cell therapies. You might be familiar, for example, in oncology, particularly blood-based cancers, there's this technology called CAR T cell therapy. It's essentially a way for us to train the body, give it essentially a code where the body can then recognize and attack cancer. So again, a novel way of treating cancer cases that has been wildly effective, and we're starting to see a lot more work in terms of expanding the success of CAR T therapies, not only in blood-based cancers, but in solid tumors. We just saw an approval for the first solid tumor approval in the U.S., and then obviously expanding that into other disease categories. So those are perhaps the ones that are sort of top of mind, and rightfully so, right? They have significant impact for the patient and the broader economy. So those are a few of the categories. The one thing I'll say is that this sort of category deserves a little bit of nuance. We're talking about treatments that, again, have curative intent. They're very novel. They're very cumbersome to manufacture. All of these are made specifically for the patient. The patient actually has their plasma collected that is then shipped via cryopreservation to a facility that then actually makes the treatment specifically for that patient. It is then transferred back to the patient. So this obviously is a little bit sort of, again, different from the regular treatment that is just off the shelf. As a result, a lot of these come with a higher price tag. So we're still early days. We're starting to see those prices decrease, but even with the high price tag, we're starting to see a long-term economic benefit for patients. And just in hemophilia A, for example, I'll give the example of Roctavian. $2.5 million in the US, 1.5 million pounds in the UK. But when we overall, for example, see the overall benefit for the patient, this treatment alone has a $7.9 million overall lifetime benefit for patients. Because again, you're removing the sort of continuous care, continuous treatment, et cetera. So even as is early days with these sort of higher price tags, we're already seeing a significant economic benefit for patients, which again points to not only sort of improved lifestyle for patients, but again, a very significant economic benefit here.
Yeah, absolutely. And I want to return to kind of what that then means for the pharma and biotech industry at large, and kind of where resources are being prioritized according to kind of what you describe as being played out at the moment. But before we do that, perhaps we can start with the more fundamental kind of element of this, which is the extent to which sequencing it has happened already, and the sequencing of the human genome, you know, how that trend's likely to play out moving forward. I think I read in the report that only 0.07% of the world's population has had their genome sequenced. So firstly, what are the biggest challenges in reaching the full potential of genomic sequencing, and how can we overcome them?
Yeah, absolutely. Again, let's sort of take a step back. Perhaps less familiar for our audience in terms of genomic sequencing. It is exactly as it sounds. It's essentially sequencing the full DNA of a patient and understanding where potential mutations might lie. Not only in terms of inherent mutations in the DNA, but also even seeing how the DNA is performing over time, whether it be through environmental impacts, lifestyle choices, age, etc. So this sort of understanding of the human DNA, or more broadly human biology, right, is sort of opening the door for the genomic technologies and genomic medicines we just chatted through to actually become possible, right? It's giving us the understanding to see this is the particular portion of DNA that needs to be altered or fixed to cure a patient, right? So when we have that broader understanding of genomic sort of DNA and sequencing, it also sort of leads us to not only how do we potentially treat or cure illnesses via genomic medicines, but also more broadly, how do we treat patients overall? What are the predispositions for illnesses? What is the overall care that the patient needs to be given if they do have a predisposition? How much more often do they need to go to their physician to make sure that we're sort of paying close attention to how things develop? So genomic sequencing is very interesting. To your point, only a very significant sort of a small sliver of the world population has had their genome sequenced, and there's a few reasons why. The first one is cost, understandably. When genomic sequencing technology started sort of becoming a portion of our broader healthcare conversation, just one sequence for one patient was around $100 million. That has decreased significantly. We're now at around $400 to $500, depending on the technology that we're speaking to. But we overall see this as a significant barrier to adoption. The industry overall has agreed the $100 mark will be sort of will allow for an inflection point in the industry for greater adoption. So that's sort of one portion as to perhaps a headwind that we have perhaps not seen as much adoption thus far. Another one that I'll say is scale. We're talking about, right, the more information we have, the more data sets that we have, the greater information we have as to perhaps what a certain sort of error, quote, or sort of noise in the DNA might actually entail. Currently, a patient might, for example, get a DNA testing, and it'll come back with a variant of unknown significance. It says, hey, we see something that's perhaps not normal in your DNA, but we don't currently know what that might entail. We don't have enough information to confidently say this might lead to a predisposition of Y illness, right? So scale is definitely important, particularly why we consider the cost of all of this becoming really sort of key for greater adoption. The last sort of point that I'll mention is very important for broader adoption is computing power. I know we chatted about this last time, Hayden, but when we think about the vast amounts of information that we need to make those informed decisions as to, hey, this particular error leads to this illness, it requires a lot of computing power, right? So I know I mentioned this last time, but for example, NVIDIA has mentioned that the current ability to sequence DNA has far outpaced the ability to actually decipher the information it sort of contains. And this is something that we're going to continue to see more and more news come out to make sure that as the price decreases and as we have more scale, we're actually able to process all of this information accordingly.
Yeah, really interesting. We'll link the episode, the previous episode that Liz and I recorded, just so people have got the context of that in a video conversation. But yeah, really, really interesting. And I mean, the point about the fact that I guess we're only 0.7% penetrated at the moment, and then if that kind of inflection point is the $100 mark, we're going to see significantly more penetration within this space past that inflection point. But when that happens, obviously we'll have vast amounts of pretty much the most sensitive data possible stored throughout the world. To what extent do Global X think about like the increase to national security risks or just kind of cybersecurity risks in general?
No, absolutely. It's a great question. Something that definitely comes up across the board. The need for cybersecurity and care of data is ever more important when we're talking about patient healthcare information, right? It's something that continues to become an area of priority for regulatory bodies. The FDA in the U.S. has made significant strides ensuring that whether it be wearable devices, whether it be electronic medical records, whether it be genomic sequencing information, is going through significantly rigorous processes to ensure cybersecurity. Again, it's sort of an ever-evolving space, but again, increasingly important. The one thing I will mention is that the healthcare industry can significantly improve their overall care of patients and can scale up significantly via utilizing all this data. Currently, this data isn't necessarily shared across the board. And one of the benefits, perhaps, of something like an AI in healthcare, which of course continues to be a topic of conversation, but I think particularly important in healthcare, a lot of this information needs to be anonymized to be able to be shared, right? A lot of this is sort of in order to be compliant and in order to be careful with the information that we're sharing, to allow physicians, for example, to learn about cases on the other side of the country or the other side of the world. Anonymized data is really important, and where perhaps we see an opportunity for artificial intelligence to not only help anonymize this information, but also ensure that we're doing it in a way that can help the industry scale, can help the industry grow and improve overall care, but also being very careful in terms of the information that's being shared and obviously having sort of very cautious approach for cybersecurity. So again, an overall evolving space, which of course, when we're talking about Global X, we do have, for example, cybersecurity focused funds and the like, but again, significant opportunity for cybersecurity or overall technology in the healthcare space.
Yeah, interesting. And I guess as ever, I think we talked about this last time as well, but when there is a convergence of two kind of significant secular trends like genomics and AI, as you just mentioned there, that as much as it elicits risks, it elicits interesting investment opportunities. And that's something obviously you can't. Yeah, fantastic. Okay, well, let's move on to how this is affecting the industry and particularly the pharma and biotech industry at large. I read in the report that companion diagnostics tests are used to help match patients to specific therapies or drugs. But before we get into how that's affecting kind of the resources and how they're being allocated business to business, just briefly explain how that process works.
Yeah, we'll take a step back perhaps as to historically how we have treated cancer. When cancer started becoming a greater portion of our conversation in terms of healthcare, it was a patient has cancer and thus all cancer patients are treated the same. And then became, a patient has lung cancer versus they have prostate cancer and those patients are treated separately or in different manners, right? The conversation has really evolved to, regardless of where cancer is present in the body, because obviously we know that it can grow significantly, we're starting to understand the underlying perhaps causes to why cancer is spreading in the body. It could be something like a BRAF mutation. It could be something like a KRAF mutation. All of this to say, very specific portions of the human body, which are supposed to work normally, if that particular portion, as perhaps seemingly insignificant as it might seem, are leading to a significant increase in cancer. If we target that specifically, it has an overall very beneficial impact on the patient outcome. So we're starting to see that the way we treat a lot of these illnesses is changing significantly. So now we're starting to see treatments for oncology be approved specifically for and again, this is sort of very in the weeds, but a KRAS G12C mutation. Very, very specific as to what it's specifically targeting. How do we know if the patient actually has that mutation versus something else? So through a companion diagnostic and through genomic sequencing, we're starting to understand specifically what is leading to growth of cancer in the body and thus what treatments we can actually take. So instead of having perhaps throwing dartboards and sort of throwing darts at a dartboard and seeing what works, we have a very clear path of what treatments we can actually utilize. And before a patient even goes on this treatment, understanding if it will have therapeutic impact, if it might have, for example, unknown or sort of disproportionate side effects to the patient. And this is really how we're starting to see treatment overall come to the market. Again, we've seen a lot of this be focused in oncology thus far, understandably so. And we're very, very excited to see sort of companion diagnostics be more and more popular across the board, not just in oncology. I will say, for example, in the U.S., we have a current total of around 175 companion diagnostic tests approved. So we're starting to definitely see sort of increasing adoption, which again has notable impact for the patients and their overall survival.
Yeah, really interesting. I want to get on to kind of then how that affects the dynamic of the industry at large, as I said. I mean, based on the efficacy of the tests, as you've just described it, we're seeing it play an increasingly important role in the success of investigational treatments. As you've described, pharma and biotech firms are increasingly partnering with or acquiring genomics companies as a result. Perhaps before we move on to the consequences of that, are there any notable examples of any M&A in this space?
Yeah, I will say there's a clear sort of winner in this case, at least on our view, a company that's really leading the way for the conversion between diagnostics and treatments, and that's Roche, having a lot of this under their own umbrella of having the companion diagnostics and having the actual treatments under, again, the Roche umbrella. It's really impressive. They have, I want to say, almost half of all of the approved companion diagnostics in the U.S., which is pretty remarkable. We're starting to see overall more conversion, whether it be partnerships of a therapeutic company partnering with a diagnostics company to ensure that when a drug is approved, that companion diagnostic test is already on the market, so the launch is a bit easier. We're also starting to see, for example, partnerships of with Roche even. Again, Roche is traditionally more so a pharmaceutical firm that also has a diagnostics arm, which is pretty unique. But we're starting to see, for example, Eli Lilly has an expected approval for an Alzheimer's drug this year. They already partnered with Roche, sort of speaking to the importance of Alzheimer's diagnosis as a way to unlock the potential revenue from an Alzheimer's treatment. So we're starting to see a lot of this occur. I think it'll be an ever-evolving conversation. But again, as we talk about companion diagnostics being more and more popular beyond oncology, it'll be interesting to see perhaps different ways that pharmaceutical companies or biotech companies are sort of leveraging their partnerships or their roles in diagnostics.
So as you've described, pharma companies are going to play an expanding role in diagnostics moving forward and have been, I suppose, over the last sort of 5 to 7 years. How exactly do Global X expect that to play out? Is that a trend that's likely to increase significantly?
We certainly think so, particularly in terms of more unconventional partnerships between diagnostic firms and pharmaceutical firms. We talked about, for example, the importance of anonymized data and the power it can have not only from governments understanding their population health, but also pharmaceutical companies understanding where the needs might be to develop sort of corresponding treatments. One way that we're starting to see this already start to grow is diagnostic firms, particularly do DNA testing or hereditary testing at a patient level, are starting to partner with pharmaceutical firms to, in an anonymized fashion, actually have access to that data. And a pharmaceutical company can thus understand this is where the overall need is of a lot of patients have this particular mutation. We're not seeing a lot of development from pharma there so far. So less sort of focus there and overall, again, help the overall population health. So I think we're going to start to see more unconventional partnerships. We're already, for example, sort of seeing a third partner, a third sort of category in terms of these partnerships, which again is AI. I was just at the JP Morgan Healthcare Conference in January. NVIDIA again presented a fully packed room, and they were even speaking to facilitating a lot of this anonymized data across the board to ensure that sort of pharma companies, diagnostic companies, and sort of more beyond that, all players in the healthcare space can have access to anonymized data that can help them sort of inform their decisions moving forward. So I think it'll be an ever-evolving space, but certainly an area that we're going to continue to sort of pay close attention to because we do think that there's a lot of opportunity for collaboration across the board.
Yeah, absolutely. And I want to move back to oncology just because it's something that you've kind of referenced a number of times as we've moved through the discussion. But actually, throughout the report, or at least this section of the report, it's identified as the maturest segment within the wider space. So oncology testing as a sector presents, as Global X have it, a significant market opportunity representing, I think, $78 billion according to the report. Perhaps you can just explain the specific ways genomics testing is impacting cancer diagnosis and treatment right now.
Yeah. When we think about, for example, just the diagnostics or even sequencing portion of oncology, and this is the hope that we expect the industry to be able to replicate beyond oncology, there's a few different ways that genomic sequencing can be utilized, not even taking into account drug discovery and developing better drugs. There's a few, right? One of them being overall screening. If you think about, for example, the opportunities for screening for cancers, currently, at least in the masses, they're very sort of location specific, whether it be, for example, you need a colonoscopy every few years after a certain age. Unfortunately, not all of them are available across the board. There's a lot of presentations for cancer, right? So currently, an estimated only 25% of cancers are actually detected via screening methods. The remaining 75% it's sort of detected when a patient is sort of further along in the process of cancer developing. They're now becoming symptomatic. They're going to the physician saying, hey, this isn't right, or I feel a lump here, and then they're being diagnosed. The correlation is, of course, the earlier we're able to detect cancer before a patient is actually symptomatic, not only the easier it is for a physician to actually be able to treat the patient, but also obviously the higher likelihood of survival for the patient. So this is increasingly important for us to find sort of novel ways to be able to screen for cancer. The ultimate goal, and this is something that, for example, genomic sequencing is currently allowing, is patient goes to their primary care physician once a year for their annual checkup. They already get a blood test measuring a host of things. The hope is that via a liquid biopsy, which is how it's referred to, they can actually screen for cancer presence, whether it be tumor shedding or tumor DNA, whatever it might be. It can actually point us to, hey, we're having sort of an overall higher incidence of a particular biomarker that thus then points the physician to say this patient needs extra attention, extra diagnostic capabilities, etc. That's one. And ultimately is one we're very, very excited about. Another one is, for example, confirmatory diagnosis. The patient, for example, is starting to have symptoms. Instead of, for example, doing a lung biopsy, which is, as you can imagine, quite sort of invasive and costly, potentially doing a liquid biopsy that way. Those are two that are very important. The other one we just spoke about, companion diagnostics, so finding the correct treatment for a patient to utilize. And the other two are actually also very interesting, which is not only testing if a drug is working, so starting to see if the overall content of tumor shedding, for example, is decreasing in the blood over time if a patient is going through treatment. It adds sort of another layer of information for the physician. Not only is, for example, a tumor shrinking or the like, we're also finding sort of more opportunity for data to help determine if the treatment is working. And the final one is recurrence monitoring. Unfortunately, about 85% of relapses are caught too late. So having an actual, again, non-invasive, cost-effective way to see if a patient that has gone into remission actually is starting to have a potential relapse, and again, catching it as early as humanly possible. So these are all sort of the ways that we're starting to see genomic sequencing have already notable impact in cancer care and cancer diagnosis. Again, not even including the portion of the importance of genomic sequencing and thus the sort of overall growth opportunity via that method for drug discovery. So again, we're very encouraged what we've seen so far. And again, we're hoping to start to replicate that in other categories.
Yeah. I mean, that's absolutely fascinating. I guess then from an investment perspective, it would be useful to understand kind of who the key players are in this market and to what extent the oncology diagnostics sphere is starting to represent a significant proportion of their overall revenue generation. Have you got anything to give us a better, truer sense of that?
Yeah, absolutely. And perhaps a good segue into sort of how Global X thinks about the overall genomic revolution. We do have a genomic ETF, ticker GNOM, and it really, for us, captures the entirety of this sort of more broader genomic shift in the healthcare space. Not only in terms of genomic medicines, like the ones we talked to, like gene editing and cell therapy, but also the second portion of it is really more so not only genomic sequencing and computational genomics, but also diagnostics. So I will say all of these play in that sort of realm. And as we talk about the opportunities for these companies or sort of these tests to become more and more popular in the healthcare space, we're talking about genomic sequencing companies, whether it be a PacBio, an Illumina, an Oxford Nanopore, those stand to significantly benefit. But also the other part of it is diagnostics companies, whether it be Myriad, whether it be Guardant Health, Exact Sciences. All of these are really playing a notable role in the broader sort of understanding of healthcare and offering sort of targeted diagnostic capabilities for the actual space. So overall, we sort of expect 2028 sales for a lot of these companies to come at around $12 billion. Again, significant runway for growth, around 21% CAGR. But we are, for example, also really encouraged by the conversion that we're seeing, not just in terms of screening diagnostics, campaign diagnostics, even monitoring or recurrence testing. We're also starting to see sort of conversion with hereditary testing companies, which, for example, are not necessarily sort of related to a specific illness, but more so a person is interested in their overall health. They take a hereditary testing sort of screener, and it might say, hey, you have an increased predisposition for Alzheimer's disease or ovarian cancer. And it's, again, helping us sort of dictate what care for the patient will look like, not just when they're diagnosed, but before then as well, to make sure that we're, again, not only detecting this as quickly as possible, but also if we have, for example, capabilities that can address the underlying issue before a patient is symptomatic via genomic medicine, actually addressing it then, which again sort of speaks to the overall symbiotic relationship between genomic testing and diagnostics and genomic medicine, which is why perhaps the Genome or Genomics and Biotechnology Fund under Global X perhaps gives a little bit of a difference and helps them to invest in broader terms.
Yeah. Okay. That's really interesting. Yeah. We'll put the fund information page in the episode description as well, because I think it would be really interesting to see how this commentary actually is reflected within the composition of the fund. But yeah, having discussed, I suppose, a maturer segment in oncology, let's move on to a more nascent segment in neurological disorders, notoriously difficult to diagnose, and the report identifies them as the highest unmet need. So a really important space. Perhaps just give us a sense to start of the total addressable market here.
Yeah, when we talk about whether it be from a therapeutic standpoint or a diagnostic standpoint, we think that the entire way that neurological disorders are cared for currently can be revolutionized for the better. I spoke to you, for example, at very early stages of cancer testing or cancer treatment, they were all treated the same. We didn't really have an understanding of how the biology works, of what were the underlying causes. And even though the presentation might be very similar between different mutations that lead to lung cancer, for example, they can be treated and should be treated completely differently. The hope is to have that happen in neurological disorders. Currently, and largely, unfortunately, a lot of these treatments are treated or a lot of these illnesses are treated exactly the same. Something like 60 to 70% of dementia patients are told that they have Alzheimer's, even though they have completely different presentations, completely different timelines or acceleration for the disease progression. We need to really understand the underlying cause for each individual patient. And that's why we think that it's an area where we haven't seen a lot of success or treatments that come through. We're starting to get a little bit of acceleration or of approval currently. But we do think that there's a lot of potential for better treatments, better diagnostic capabilities, and overall better care for patients. We really want to make sure that the overall progression of care for these patients improves across the board. And that's why we think it's one of the areas of highest unmet need. Again, obviously things like Alzheimer's comes to mind, but even beyond that, even thinking about, for example, mental health, it's a notoriously difficult space to understand because you're largely relying on patient-derived information. a lot of this is, does the patient feel better? Does the patient feel less anxious? Is the patient able to focus, et cetera, et cetera? There's no direct measure, right, of how things are working or how to diagnose this. We do think that overall that this space stands to be revolutionized across the board.
Yeah, really interesting. I mean, I guess focusing on one of those specific diseases, I mean, if we pick Alzheimer's, for example, given the limitations you just described of the traditional diagnostic methods, particularly in respect to that disease, how can these new non-invasive tests contribute to earlier detection and potentially even prevention of the disease, if even that's something that, you know, is ultimately the aim with this technology?
Absolutely. And it's a great point, right? When we're talking about, for example, I just spoke to, we're starting to get a shift of the treatments that are approved for Alzheimer's. We've seen a couple in the last few years. We're expecting an additional one this year from Eli Lilly that really speaks to improved overall care. Overall, though, the sort of data that we've seen thus far is these treatments work in early stages of the disease, which really speaks to not only is it important overall to understand where a patient sort of stands, not progression, but the earlier we catch it, easier it is to treat. Same as, for example, other illnesses. So for context as to how Alzheimer's, for example, is currently diagnosed, there's a few different methods. One is a PET scan, an overall imaging sort of machine. It can be quite costly. In the U.S., it's about $5,000, and there's only 2,000 PET centers in the U.S., so it's not really scalable. It's very expensive. The alternative, at least currently, is spinal fluid tests. As you can imagine, it's quite invasive. Again, it's a little bit cheaper, $1,000, and it's a little bit more scalable, but it's still really cumbersome to actually have patients go through this to either confirm it. And again, we're talking about not only a potential diagnostic test occurring once just to confirm diagnosis, but multiple times to see how that disease is progressing, or even if a treatment is working, right? So it makes it a little bit more complicated as to how we think about diagnosis or even care of these patients. The alternative, similar to, for example, a blood-based test for cancer diagnosis, is a blood or plasma test that can actually also show, for example, whether it be specific proteins that accumulate in the brain as a result of Alzheimer's, et cetera, that can point us to, again, a more scalable, cheaper, around $400 is the estimate currently. That can, again, make it more accessible for patients to have this type of screening. Overall, again, why does it matter? When we're talking about, for example, the likelihood of success for these treatments, it's imperative that we have as early of a diagnosis as possible. And that's we're starting to see, for example, increasing partnerships as a result. We've seen approvals. We already saw, for example, Eli Lilly partner with Roche to develop better and improved diagnostic cases to actually aid in the adoption of the treatment once approved. So we're starting to see this be increasingly important overall. And overall, again, the overall goal is the touch predisposition, which we talked about, being able to hopefully address it later on if we have improved therapeutics that can sort of perhaps pinpoint exactly what's happening in the DNA or RNA or proteins, whatever it might be, pinpoint it directly and address it before the patient is symptomatic. But overall, really having a more sort of scalable, improved, seamless sort of care continuum for patients with Alzheimer's.
Yeah, fascinating. And there was a nice comparison, I think, of the different testing methods and kind of to what, you know, how much they cost, how scalable they were as a result. So we'll throw that up in the video as well, because I think it's really important to see those side by side. To finish then, and like we did last time, we've discussed some really exciting technologies so far, but we ask all of our guests for their next big idea. It's the name of the show. So perhaps if we can just finish on a prediction about where this space is headed. Is there a particular development company or even a technology that particularly excites you when you look at the next 5 to 10 years?
I think certainly. I think one of the ones that we're particularly hopeful for is the manufacturing of cell and gene therapies. Again, we're speaking to our Genomics and Biotechnology Fund has the entirety of the genomics revolution, right? Life sciences companies, diagnostic companies, and pharma and biotech. If you think about the former of that, the manufacturing portion of cell and gene therapies is really quite cumbersome. The more we understand how different potential delivery methods, for example, might work, we're starting to see the potential for off-the-shelf cell and gene therapy, which would be so revolutionary in terms of the greater availability of these treatments, but also in terms of the cost. I think that's one of the areas where life science companies will play a pivotal role in sort of achieving this, and again, decreasing the cost of these treatments to a point where more patients can actually benefit from these curative sort of illnesses or treatment for these illnesses. Again, that'll ultimately lead to better insurance coverage and the like. The other one that I'll say is more broadly, the current treatments that are addressed by these technologies or these treatments has largely been focused around blood-based diseases, whether it be sickle cell disease or hemophilia A, or blood-based cancers. The opportunity for us to see a CAR-T therapy for lupus or for multiple sclerosis, areas that have, again, significant unmet need for these patients, that we're starting to now validate a lot of these treatments and say, hey, we can actually replicate this elsewhere in areas where we have historically really failed at having a strong sort of toolkit for treatment. That's one of the areas that we're really excited about, whether it be small biotech or even large pharma starting to develop more and more in this regard is where we're saying we're really excited. And the last one is diagnostics. And we spoke to the importance of this. Really, when we think about it, it's quite baffling the fact that we don't have greater availability of even, for example, oncology testing. And even when we think about, for example, the actual sort of adherence of patients that have or are past the age where they should be going to get a colonoscopy or a similar test every so often, it currently doesn't happen as it should. If we make it as easy as possible for patients to actually have access to this technology, we're going to start to see hopefully an improvement of overall outcomes in patients. So we're starting to see every single facet of healthcare change the result of genomic technology. We're so encouraged. Again, there's so many companies and so much nuance to each particular technology, which of course is why we think sort of a basket approach is the best way to tackle this, because we think that there's a lot of different companies that can stand to benefit as a result. And overall, the overall goal here, of course, is to improve patient lives, make it easier for patients to get a diagnosis for a really cumbersome, really difficult disorder, and no longer for it to be a death sentence, right? That's the overall goal. So again, we think there's opportunity across the board, and we could not be more excited for the overall healthcare space at this time. Again, I think we stand at a point for revolution to be inevitable. And again, we're very encouraged by what we're seeing.
Yeah, I mean, it is absolutely fascinating. It does feel, as you've kind of alluded to there, that we're at the precipice or actually potentially even going through a real inflection point for the mass adoption of some of the technologies that we've discussed today. So yeah, okay, great. Well, as ever, we'll watch this space. And like last time, a really fascinating conversation, Liz. Real pleasure to speak to you and look forward to speaking again soon.
You as well. Thank you so much.